Well, hello and welcome to Barker's Integrated Math 2. And so when you find yourself doing online work, we'll be working mostly in Math Excel. And this is kind of what the home screen looks like. And it's okay, but it's not great. The best way to navigate this is on the left here. Go right to homework and tests. So you should have plenty of time in class to have time with the device to complete all the work in class. You shouldn't have to take this home or try to work on it at home. However, if you would like more class time to work on other classes, or just to read quietly, or if you have some anxiety around math, you just want to get it done sooner, you can definitely do this at home and free up time at school. So you have options. And this is what it looks like. So you go to homework and tests. The newest assignments will always be on top. So currently there's only one assignment. So you just click on it. And so you'll see a little description here of when it's due. So this is actually Sunday at midnight. Let's see what else. Title explaining what you're getting into. Number of attempts per question. You can keep taking them as many as you like. Even if you get them right, you can keep doing the same question if it's a hard one and you want to keep doing it. You could actually continue working on it even past the due date. So I don't want people to give up if they miss the due date. And so it's a 20% deduction. Now, what should be said is that homework is not directly graded. The only effect this 20% deduction has is that it makes it a little bit harder to take a quiz. So normally when you take a quiz, you have to have at least 75% complete. So if it's 20% deducted, you pretty much have to have it almost completely complete to quiz, if that makes sense. Sometimes there's a few harder problems. So as we go through these, I'll point out the harder problems. So there's kind of a mix of problems. They're not in order of difficulty. So if you come across a hard problem, feel free to skip it and then come back to it. If you're just trying to pass this class with a C, I highly recommend doing these problems before the due date, and then you can take the quiz and kind of not do the harder questions. So for the first week, we're really just mostly looking at rational and irrational numbers. So I'll show you kind of this interface. So which numbers are irrational, okay? So we have a little question help over here, and I'll show you what that looks like. So irrational numbers have decimals that go on forever and never repeat. So let's look what that looks like a little bit. So I'm going to use a calculator here to kind of show you. Here's my calculator. And so if the calculator's here, you're welcome to use a calculator. Okay. If the calculator's not here, you're supposed to be able to do these questions without a calculator. Okay. You can also watch their own video. This is not my video. I have, this video is my video, but the video that's here is their the publisher's video. So you can watch that. You can watch a walkthrough of how to do it. That's kind of shows you step by step how to do it. To help me solve this option, some people like it, so you're welcome to try it. But I generally find that this option is more difficult than actually just doing the problem by viewing examples. So help me solve this is an option, but it makes it really hard to do it, and then you have to do a new one after. So it doesn't let you. It's better if you view example. If you view an example, you can still just do one problem before moving on. You can always email me. So if you want, you can shoot me an email this way. Nice, easy way to send me an email. You can print the problem if you'd like to. So, but it'd have to be somewhere not inside my classroom because none of my computers are connected to any printer. So you can't do it from the classroom, but you can print it if you have a printer. So going back to the problem here, 25 is actually the answer, and I'll show you why. So if we put in 25 and then square root it, we get 5 back. So that's not an unending decimal. So if we put in 17, for instance, I'll clear it, 17 in. So you see this decimal keeps going. There's no pattern that repeats. And then this calculator holds so many decimals, but the decimal really does keep going. It doesn't terminate at 8. It just keeps going. So that's irrational. So we're going to skip 17 because it's asking for which numbers are irrational. So 25 is irrational. We've got to read the question carefully. I almost made an error here. So which numbers are irrational? So 17, oops, these aren't in the same order. 17 is irrational. 100, many of you probably know 100, the square root of 100 is 10. You can use a calculator to verify. So that is rational, and then 41 is going to be the other one. So it says select all that apply. So you really have to kind of pay attention to everything that's going on. Now say you knew 17 was irrational, but not 41. You checked your answer. It'll tell you it's not correct and give you another try. So then if you did get the correct answer, it marks it correct. So I'm not going to go on the next question yet. So see right here, it's correct. So if it's correct or if it's incorrect, you can always click similar question. If you click similar question, it'll give you a new question, as it does here. And if you get it right, this becomes green. So I'm going to get it wrong a few times, just so you can see what happens. If you do final check and get it wrong, it tells you the correct answer. This would be C and D. It's asking for irrational again. These are both irrational numbers. So that's okay. So you can save the, I got it right. I'm going to say I save this attempt because I want to show you. So if you get the X up here, say, oh, well, I don't want to not, I want a point. So right now I have 0 out of 1 points. Roll a similar question. It's thinking. Why isn't it working? Reload the page. Okay. So it did reload. I was confused. Okay, so irrationals are 17 and 47. Okay. So once you get it right, oh wait. Okay, so now it shows you it's right. You get the point. So I have a point here. So here's my total percentage. This percentage over here needs to get up to 75 to quiz. Okay. And I'll explain more in class why, but it's just so that I think you've demonstrated that you're ready to quiz. All right, so going on, we'll go to question 2. You can also just go this little arrow here. Which numbers are rational? The dots indicate the pattern continues. So this goes on forever, but there's just 9s over and over again. So that is rational. So 1 is rational. And then number 2 here has 9.123, but then it stops. So it's terminating decimals. This is also rational. So the formal definition of a rational number is that it can be put in a fraction, like a ratio, a quotient. So both of these have some fraction equivalent. Okay, the last one though doesn't. It has a 909, 909, so it almost looks like the pattern's repeating right here, but then it has 2 9s in a row. So the pattern's not quite repeating. So 1 and 2 are the most likely rational numbers. And that's the answer they wanted. Okay, so it's a little confusing, and it gets a little bit worse. I'll show you here. So is this rational, irrational? So let's look at the decimal. 323, 323, 3, and this one should be a 2 right here. So this is most likely irrational. Okay. Find the set of numbers to which -5/9 belongs. So this is more of a vocabulary question. So I'll go through each one of these and explain what they are. Integers are just whole numbers. 5/9 is not a whole number, so it does not belong to that category. Natural numbers are like counting numbers. So it starts with 1, 2, 3, 4, 5, 6 kind of thing. Whole numbers and integers are pretty much synonymous. They pretty much mean the same thing. So far, none of these are categories that this number belongs to. Irrational numbers are numbers that cannot be represented as a fraction. Well, this is a fraction, so it's not irrational. So it's rational because it's a fraction. That's what kind of rational numbers are. It's anything that can be written as a fraction. So even like the number 1. A number 1 is a rational number because you could put 1 over 1, which is a fraction that's equivalent to 1. Hope that makes sense. Real numbers are any number that's not imaginary. So this doesn't have an I component, so this is also a real number. Irrational numbers are typically real numbers as well, so just keep that in mind. So yeah, these are the only 2 categories this number belongs to. And if you weren't sure, I think let's give you an example. Yeah, they explain what all these are, so that's a little bit helpful. It's kind of like think of this like your textbook or your cheat sheet. All right, next question. Which numbers are rational? So all of these are rational. Rational. 3, 8 repeating is rational because it's 3, 8 over and over again. 9/16 is a fraction, so that's rational. 0 is rational. -7 is rational. So almost all these are rational. Pi, however, is not rational. That is, pi is a concept of how many times the diameter goes into the circumference of a circle, and it's always the same. It's roughly 3.14, but that decimal goes on forever, never repeats. So pi is not rational. So this question is probably one of the harder ones. And so it says the numbers 1.77, 1.88, repeating, are both rational numbers. Okay. Which of the following is an irrational number between these two? So this number right here, this 2.778777, is most likely irrational. However, it's not between these two. So the ones we're after are this one and this one. This one is not irrational. It is rational. It stops. It's a terminating decimal, so that means it can be written as a fraction. So this one is rational. So these two are the ones that are irrational. So those are the irrational ones between these two numbers. So this one's slightly above 1.77, so it's between these two, and this one's slightly, that 7 in there makes it slightly less than this one. So it's really kind of a tricky question. But yeah, I hope that clarifies some things with it. Again, you can always view an example. It explains it pretty well. So the square root of 86 is not rational. It's irrational. So on a number line, between which two consecutive whole numbers would the square root of 86 be located? So the square root of 81 is 9, and the square root of 100 is 10. So this is between 9 and 10. So if you didn't know that, you could get a calculator and 86 square root, so it's between 9 and 10. That number's between two whole numbers. Which consecutive whole numbers? 9 and 10. Consecutive just means next to each other. Two whole numbers next to each other. 9 and 10 are next to each other. The square root of 86 is between those two. This is the same thing. A number line which two consecutive whole numbers is between. This is between. So 11 squared is 121. So this is right above 11. So it's going to be between 11 and 12. You can use the calculator to figure that out, but it helps if you know some times tables. So this is between 121 and 144, which is between 11 and 12. And that's actually how the way they want you to solve it. You're not really supposed to use a calculator on these, but just because we're just getting started, it's okay to use a calculator to kind of explore what's happening here. What is the first step in finding which two numbers? So this is sort of interesting. How would you find these two numbers? Well, I guess it depends on your tactic. If you're just square rooting it, but these both imply that we're not using a calculator. Okay, so find the two perfect squares closest to 765. That's probably it. That would probably be it. So this is probably the first step. We want to find the two, kind of like I was doing in the previous one, where I was finding the perfect square of 11, perfect square of 12, and knew that 765. So that's probably the first step. We could also just evaluate it with a calculator, but I don't think that's what they're after. So let's try A and see if that's what they wanted. So yeah, that's kind of what I was doing. That's the non-calculator of doing it. You'd multiply the same number twice and see how close you get to 765. Oh, there's one other part. On a number line, between which two whole numbers would this be located? Okay, so this is a pretty big number. If you were not allowed to use a calculator, you could go through each of these and just multiply them to themselves, like 27 times 27, and see how close you got to 765. But since we are allowed to use a calculator, I'm saying you can use a calculator. 765 square root, it's between 27 and 28, right? So it's going to be that one. That would be pretty hard to do without a calculator. It would take a while anyway. So I hope you're kind of seeing a pattern here of what we're doing. So this is sort of introduction to roots. We're kind of looking at square roots right now. These are irrational numbers. We're kind of figuring out which two rational numbers they belong to. So 13 squared is 169, and 14 squared is 198. So I know this is between 13 and 14. If you did not know that, you could use a calculator. The volume displaced in the engine is the square root of 50 liters. Between which two consecutive whole numbers is the square root of 50? So 49 is a perfect square. 7 squared is 49. And then the next one would be 64, so it would be between 7 and 8. Really close to 7, though. This is really close to 7. Last one. Wait, what? Oh, that was it. That was the last one. Okay, so that's the homework. So if you go, just so if you're curious, you can save it. It saves in real time, but you want to save it so it applies to your score. And then you can always go to results, or I think it's results. So it took me about 12 minutes to complete it. So I was going through it pretty quickly. You can always go back to the problem I was on. If it doesn't make sense, please ask questions, okay? I went through this pretty quickly. So I hope that's helpful for the classwork in Math Excel.